Today in our video we are going to look at introduction to matrices in MATLAB. How we do matrix calculation in MATLAB. Okay, let's go into the video. Over here in our window, we could see that we have our editor window, and then if we punch the editor on the right side of our window, it will also show us a command window. So we have a command window and then the editor window. So how do we put in the data? So we have our matrix A. The matrix A, we have 3 by 3 matrix. We have 2, 5, and minus 3, which is terminated with semicolon. So we have the first row, and the second row, and the third row. So we have our matrix A. Then how do we do determinant calculation? We don't need any length or any parenthetic calculations. We just have to enter that A to give us a calculation. And then the inverse of A, that one too, we just have to enter inv A to give us a output. Okay, for trace A too, we just have to enter trace A. That one also will execute as for us, or the computer will do all the calculations for us. Let's move also to adjoint A. For adjoint A to that one there, for that one it has a formula. We have to multiply inverse of A by determinant of A for it to give us the calculation, or for the computer to give us the calculation. Okay, we are moving on to transpose of A. We could see that the transpose A or transpose was having power T, but over here the transpose, the sign of the transpose is apostrophe. The apostrophe sign has been replaced the T or apostrophe has replaced the T sign. Okay, and the cofactor of B also, we have our formula as adjoint transpose, or transpose of adjoint, or adjoint transpose. We could see that we couldn't enter adjoint, or we couldn't enter adjoint over here, or just transpose, adjoint transpose. Why? Because the computer cannot recognize adjoints. It cannot recognize adjoints. So we entered inverse times determinant, all into brackets, and then raised to the power inverse. Okay, raised to the power transpose. Okay, let's go, or let's put everything into the command window. So we are going to copy everything. Let's first copy the matrix. Okay, Control plus C to copy, and then Control plus V to paste. You can see that the matrix A has given us the output. Okay, let's make it fast, and then copy the determinants. Okay, Control plus C to copy, and then Control plus V to paste. That A has also given us all the calculation. And let's continue. We go to the inverse, and then the inverse also Control plus C to copy, and then Control plus V also give us the answer. After the inverse, we go to the adjoint. Control plus C in the adjoint, and then we go to the trace A. You copy, Control C, copy, and then Control V, paste. The trace also gave us 3. The trace gave us 3. Then the transpose. Control C, copy the transpose, and then Control V. Sorry, because this is because I pasted C, or I entered C before the transfer. That's why it gave us the undefined function. So let's paste, or let's check what I entered over here. Okay. This is because I entered C before the comments. So you delete the C over here. Delete the C over here and copy it again. Okay. Control C to copy, and then Control V to paste. Okay, you will see that A transpose was also this. It negates this. It negates this line. Yeah, that's why we have a transpose. Okay, let us continue. We have gotten into the cofactor. Okay, we highlight and then Control C to copy, and then we paste, Control V. Then we have gotten an answer over here. We will see that everything gave us the output. So the computer will be doing the calculation and give us the answer. So what we have to bear in mind is that the cofactor is equal to or equivalent to the adjacent, or the transpose of the adjacent, the transpose of the adjoint. That's the cofactor. And then the adjoint is inverse of A multiplying the determinant of A. Okay, this is how we do our calculations, or our basic calculations of matrices in MATLAB. Thank you for everyone for giving me his or